5H inverses. Today we're learning about the relationship between exponentials and logs. What you need to be able to do is find the domain and the range of the inverse function, and then find the inverse function by rearranging a rule. As we have spoken about before, logs and exponentials are inverses of each other. So what that means is that we have our exponential graph, and you can see that all of the x and the y values have essentially swapped to give us our logarithmic graph. They are also opposites in the same way that, for example, x squared and square root of x are inverses of each other. And the same idea happens that if you were to input one into the other, it would end up cancelling out essentially. And I just draw your attention to that because of these two properties that are pretty cool to use. So if we have log a to the power of x, that cancels out. And then a to the power of log a x, that also cancels out. So inverses, when you are to do the composite function of them, will result in just the value of x. So to find the inverse function, it's very much like all the other times that we've found them. We're just going to now practice it specifically with exponentials and logs. We're going to do this question with both the use of technology and using a CAS calculator. Sometimes with a CAS, the exponential, the inverse comes out really weird. So if you get a really strange answer, like they just haven't rearranged it properly, then I would always just suggest to ignore that and to work with by hand. In general, I just prefer to find inverses by hand because I just don't trust the CAS to give me a good enough answer. So example 20 says find the inverse of this function, state the domain and the range of the inverse. So first we're going to do it without the use of technology. Now this is my original function here, and all I have to do is rearrange it using the inverse properties. So I'm going to swap the x and y, and now I just need to get y by itself. That's the aim. So first thing I'm going to do is I'm going to take 1 over, and then I'm going to divide by 3. Now to take the e over, we'll take the log of both sides, and that will give me log e x minus 1 on 3. Now, it also asks us to state the domain and range. Either you can do that by looking at the actual inverse function, or you can find the domain and range of the original and just swap it over. So whatever you find it easier. Now, the original function has an asymptote at x equals 1. Will look something like this. So the domain is r, and the range is 1 to infinity. So that must mean the opposite. So this is 1 to infinity, and the range will be r. Just to confirm, this is a log graph. Remember, to be able to see the true translation, you need to take out any dilations. That has moved over to the one by right, and there's no reflection, so it'll look like that. So that is correct there. Now, to practice this on the CAS calculator, we're going to use this concept of needing to swap and solve for y. So first thing I'm going to do is I'm going to go ahead and put in my solve function. And then I'm going to type in my function, but I'm going to have swapped the x and y, and then I'm going to ask the calculator to solve it for me. So that'll be x is equal to 3 e to the power of y, and then the plus 1 is on the side, comma, and we're trying to solve for y. When I press enter, it actually gives me the exact same function, which is nice. A lot of the time it doesn't. So I do want to also point out that ln in the calculator, and you can also write it by hand, just means the natural log, which is log e. So we actually get exactly the same as what we've already found. So that's log e x minus 1 on 3. It does specifically give us a domain as well. So x needs to be greater than 1, otherwise this is not going to be valid. Okay, fantastic. Let's try the next one, example 21. Find the inverse of this particular function, state the domain and the range of the inverse. So firstly, without the use of technology, so same idea. We'll write out the equation as it is first. I'll then swap x and y. I did forget a plus 1 at the end. It's really important. And now we're on a journey to solve for y. So first thing I'm going to do is take the 1 over, and I can also divide by 2. Oops, that's a 10. Now to take that base 10 over, that'll just appear as an exponential. And then finally, I can take that 1 over. Plus 1 should actually be nice and big. Okay, so let's go ahead and find the domain and the range. So we're going to do that I'll do the same thing. I'll just do it from the original. Again, you can look at the inverse, but whatever you prefer. So this is a log. It's moved over to the right by 1. No reflections or anything like that, so it should look like that. Domain, therefore, will be from 1 to infinity, and the range is just r. That means that for this function, the domain should be r, and the range should be 1 to infinity. Just to check that that asymptote is correct, we can see that the whole graph has moved up by 1, and so the rest of the graph will look like that. So that's correct. All right, practicing this once again on your CAS calculator. So we are going to just go ahead and solve, and then we will type in the function, but swap the x and the y. Again, I'm not trusting it to give me a good answer, but we'll just see how we go. Now, because this is not the natural log, you can't just type in ln. You actually need to use log and change the base. And that should be a y, because I'm swapping the x and the y. All right, just to double check that I got the right equation. All looks good, comma, y, and let's see what happens. There you go. It actually looks pretty good. So that's 10 to the power of x on 2 plus a half, and they've put it on, let's see, it's not exactly the same. They put it on 10 plus 1. So what they've done there, the reason that they've got that on 10 is, I'll just write it out what they have given us, and then I'll explain it. So they've given us this. And this is what I mean by it's just sometimes I don't think it's worth using the CAS calculator. If you think about this, that's 10 to the power of 1, and then we're dividing the two bases. So when you divide, you take away the bottom base. So that will result in 10 to the x on 2 minus a half, which is exactly what we've got there. Um, and then of course there's the plus 1. But they're just doing that, I suppose, so they can try to avoid the negative, but there's really no point to do that. So sometimes if you're in a test and you just want to check that you're correct and then you see a totally different answer, it might stress you out. So I would just rather trust that you've done it correctly by hand than go to the CAS calculator. But anyway, essentially that's how you would do it there.